Oh, way too zoomed in. All right, so first example says a computer company makes desktop and laptop computers at factories in 3 states, California, Texas, and New York. The California factory produces 40% of the company's computers. The Texas factory makes 25%, and the remaining 35% are manufactured in New York. Of the computers made in California, 75% are laptops. Of those made in Texas and New York, 70% and 50% respectively are laptops. All computers are first shipped to a distribution center in Missouri before being sent out to stores. Suppose we select a computer at random from the distribution center. It's way too many states. This company needs to simplify things. So tree diagrams, they're going to look really similar to our experimental outlines. We're going to have words, and then we're going to have lines that lead to other stuff, and along the lines we put our probabilities. So what we're working with is that we're going to select a computer at random. So we're going to start with computer. It tells us that the computers are made at factories in 3 states, California, Texas, and New York. So from computer, I'm going to have 3 lines. And I'm going to California, Texas, New York. Now it does tell me in there what percent of the computers are manufactured in each of those states. Thank you. What's the All right. So California makes 40%. So along the line to California, I'm going to have 40% as a decimal. So 0.4. Texas makes 25%. So on the line to Texas, I have 25% as a decimal. And then it tells us the remaining 35% are made in New York. So along that line, I made that line a lot more diagonal. I'm sorry, say that again? Yes. Next Tuesday. But, okay. The test is next Tuesday. We're here. Tomorrow we do 5.3 day 3. I don't see you on Friday. Monday we'll review, and we'll get rid of one of the reviews and still test on the 14th. I don't see you on that Wednesday. Thursday the 16th I see you, and we'll have a movie, or you can finish your test.
Math movie.
No, Christmas movie. We watch math movies later in this class. Sam, stop talking to him so he can hear me.
No, I'm not. Wait, what math movies are you?
Moneyball, A Beautiful Mind, and sometimes no. That is not an okay movie for school. Wolf of Wall Street. No. Moneyball.
It does.
No. All right.
It's such a good movie, Leonardo.
No. All right. So now that I have my 3 states, it then tells me that there are a certain percent from each state that are laptops, and then the other one is desktop. So California makes desktop and laptop computers. Texas also makes both desktop and laptop. And New York also makes both. Excuse me. And then along the lines leading to each type from each state, I will put the respective percents. So it tells me that California makes 75% laptops. So California to laptop, I'm going to put 0.75, which means what percent of computers in California are desktops? 25. So I have 0.25 here. Then it tells us the ones made in Texas and New York, 70 and 50% respectively are laptops. So that means in Texas, I have 70% laptops. So Texas to laptop, I'm going to put 0.7, which means what percent are desktops? So we're going to put 0.3 there. And then, excuse me, New York is 50% laptops, which means we also have 50% desktops. And then we're going to have our last branch that goes out and gives us the total for each one. So if I were to choose a computer and it came from California and was a desktop, this number here is going to tell me the probability that it was a desktop from California. And the way I get these last numbers is I multiply the numbers of the branches that lead there. So for this one, from computer I go 0.4, 0.25, so I'm going to multiply those together to get my number at the end of that branch. So we get 0.1. I'm going to put that over there. So then California laptop, 0.43 times 0.75 is 0.3. Then Texas desktop, 0.25 times 0.3 is 0.075. And Texas laptop, 0.25 times 0.7, which is 0.175. Then New York, 0.35 times 0.5 for a New York desktop, which is also 0.175, and that will also be a New York laptop. Now if I did my tree diagram correctly, these last branches, when I add them together, should equal 1, because those are all the probabilities of the possible outcomes. So 0.1 plus 0.3 plus 0.075 plus 0.175 plus 0.175 plus 0.175, I got 1. So that is a tree diagram. Any questions? All right. So then the other part of that question is to find the probability that the computer is a laptop. So we want to find The probability the computer is a laptop. It doesn't say anything about which state it comes from, just that it's a laptop. So a computer from California, that's a laptop, that has a probability of 0.3. Computer from Texas, that's a laptop, has a probability of 0.175. And a computer from New York, that's a laptop, also 0.175. So the probability that a computer picked at random is a laptop is 0.3 plus 0.175 plus 0.175. So 0.65. Questions? All right, so you guys are going to do the tree diagram for the next question. I picked on Noah. In years past, I've always had this class either first or second period, so it was always first thing on one of the days. And I always had a kid who was always tardy. Noah's kind of tardy. He gets up and goes to the bathroom a lot, so I picked on him. So we're going to say Noah hits the snooze bar on his alarm clock on 60% of school days. If he doesn't hit the snooze bar, there is a 0.9 probability that he makes it to class on time. However, if he hits the snooze bar, there is only a 0.7 probability that he makes it to class on time. On a randomly chosen day, what's the probability that Noah is late for class? You guys are going to make the tree diagram, and then you're going to answer this question. There is another probability question down here. I want you to try that one, although I haven't talked about how to do it with a tree diagram. So make your tree diagram and answer that one. Try that one, but we'll talk about that one as a group. this one first. What's the probability of this thing? And then that one, I was going to see if somebody got it, but if not, I'll go over. Don't forget, I kind of hid the first question up in the paragraph. Don't forget to answer that question I answered. And you can try the bottom question, or you can wait and we'll go over it. Hannah's gonna put the tree diagram up there for us. Where are your final branches? No, your final branches should have numbers. Not the right ones, it should be that times that. Oh. Who said my name already?
Hello.
So friends,
Hello. No. You actually.
I'm not hating you guys, I'm hating myself. I'm basically like, but no, I'm switching to not out of stock. Makes sense.
And you just add it to your
Still like.
No distraction.
Wait.
Yeah. Thanks, Sam. Thank you, sir. And thank you, Hannah. All right. This word doesn't matter so much. Some of you put day, some of you put Noah, some of you, I think, put alarm clock. That word doesn't matter so much. Okay? The rest of it is what matters. We hit the snooze bar or we don't hit the snooze bar, and then from each of those, Noah's either on time or late to school. I saw quite a few of you that got that part done, and then you forgot the numbers to multiply them to get the final branches, okay? And then Sam came up and gave us the probability that Noah is late. So that would come from him hitting snooze and being late, plus him not hitting snooze, but still ending up late to class. Any questions? All right, Jillian is going to come show us the bottom one. Alright, so this question says, suppose that Noah is late for school. So you're given a condition. What's the probability that he hit the snooze bar that morning? So she set it up. Probability he hit snooze, given he was late for school. And we use our conditional probability rule that we learned last time. So to find the probability for a conditional, you take the probability of him hitting snooze and being late and divide it by the probability he's late. So him hitting snooze and being late, we follow our tree diagram. Snooze and late is this one right here, 0.18. So she put 0.18 over 1. Then divide by the probability of the given condition, which is that he was late to class. And we found that up here. Sam gave us that answer. It's 0.22. So we divide by 0.22 out of 1. She then showed that the 1's cancel out, and you have 0.18 divided by 0.22, which is approximately 0.818. Questions?
I got 0.0396.
Did you have 0.18 divided by 0.22?
Yeah.
You must have just typed something wrong. Any questions? Alrighty. So on this one, it tells us that about 55% of high school students participate in a school athletic team at some level. And about 5% of those athletes go on to play on a college team in the NCAA. I'm going to show you how to get the general multiplication rule so that we can answer the question, what percent of high school students play a sport in high school and then go on to play a sport in the NCAA. So just because you guys know me, I'm lazy, we're going to say high school. They played in high school, play a high school sport, so that I don't have to write it out each time. And then NCAA is what I'm going to use for my abbreviation. For the other one, that means they play in college. So, we're told that 55% of high school students participate in a school athletic team at some level. So the probability that a randomly chosen high school student plays on some sort of sports team is 0.55. Then we're told about 5% of these athletes. That means it's a conditional probability. So we're only talking about the athletes who played in high school. So this tells me the probability that they go on to play in college given they played in high school is 0.05. Sorry, I'm just thinking my handwriting's too big to fit this in the center, but I'm going to try. Alright, so I'm going to show you how we get the general multiplication rule for the probability of A and B. Yeah, I'm not going to fit it in the middle. I just can't. Sorry. I'm going to put it down here. I need more space. So yesterday I taught you guys that the probability of B given A is found by the probability of A and B divided by the probability of A. So here I'm given 2 of the 3 and I'm asked to find the other one. So I'm given probability of high school and then the probability that they play in the NCAA given they played in high school. And I'm asked to find the probability that they played in high school and play in the NCAA. So I have all 3 parts, just not in the form I showed you yesterday. So we can use a little bit of algebra to help us solve for the probability of A and B. So I would multiply by the probability of A on both sides to get the probability of A and B by itself. Sorry. So our general multiplication rule tells us that the probability of A and B can be found by taking the probability of B given A happened and multiplying it by the probability of A. Key thing to notice here, A was given and we're multiplying by the probability of A. Whatever the given condition is what you have to multiply by for this general multiplication rule to work. So probability of A and B is found by the probability of B given A times the probability of A. So here, the question is what percent of high school students play a sport in high school and go on to play a sport in the NCAA. So it's asking us the probability of high school and NCAA. So I'm going to take the probability of NCAA given, given that they played in high school, and I'm going to multiply by the probability that they played a sport in high school. So we end up with 0.05 times 0.55. Which is 0.0275. Questions? All right, I want you guys to try the exit task. What time did we get out today?
12 minutes.
Okay, you have time to try the exit task. The exit task can be done using the general multiplication rule, or it can be done with a tree diagram. 2 ways to get the same answer. Maybe after the X is passed. He said, are we gonna watch the announcements? And I said, maybe after the exit. I thought you were logging into your,
I did do it.
oh, you just had to log in, that was it? Oh, but you're in my class. I take yours.
No, I'm saying.
So you don't actually have to do it right now. Well, then what's the point of seeing us doing something? And you know, today's an 8 a.m. Here's my food.
Wait, no, this is.
No, then what is the point?
I don't know.
Need help.
I'll be right there, Mariana. Okay, so what percent reserves do we have to redraw?
It says,
No, it's not up there.
doesn't it say this?
That says if he had to serve again.
Like, so it's in minutes, it'd be 37.
And then from there, you have to either got the point or he didn't get the point.
Oh, it's a 70.
Yeah.
Okay.
Does that make sense?
Yeah.
Okay. Please look me on board. Alright, Haley's gonna, she's gonna show how to use the general multiplication rule to get the answer.
Well, isn't it like a 2 Yeah, this is what anyone bought those? Also, I don't know, bro. I'm kind of boycotting it though.
Rice cake.
I don't know, maybe we should bring back the stand.
I like this sweater, Tyler.
Oh.
What do you do?
Make it yourself.
I did not. My mom said it's going to school.
Hold on, I'm gonna explain. Maybe it'll help. Alright, so the question is, what's the probability that he makes his first serve and wins the point? So probability, first serve, and wins. So she has W for win. So the general multiplication rule tells us that we need to take the probability he wins the point given he made his first serve times the probability he makes his first serve. Both of those probabilities are stated in the problem. So probability he wins the point given his first serve was in is right here. So when he makes his first serve, he wins the 0.78% of the time. So she has 0.78. And then we have to multiply by the probability he makes his first serve, which is right here. He makes his first serve 63% of the time. So when we multiply them, we get 0.4914. Those of you that we're working with the tree diagram. Again, this first word that you put here really doesn't matter. When I made mine, I said first serve. And he either makes it or he misses, right? That's easier than saying not make. So miss or make. So it tells us he makes it 63% of the time, which means what percent is he missing? 0.37. And then from there, he either wins the point, I'm just going to say point or no point. And same thing when he misses his first serve. He either gets the point or he doesn't. And it tells us that he makes his first serve and wins the point 78% of the time, which means he makes and doesn't win the point 22% of the time. And then it tells us that when he missed the first serve and had to serve again, he wins 57% of the points, which means that when he misses and tries again, he doesn't get a point 43% of the time. So using a tree diagram is possible with this, but it's kind of overkill because the only one we need to know is this one right here. I mean, you can find all the other probabilities, but the question is asking for this one. So tree diagrams are helpful. Sometimes they require you doing more work than necessary for the problem. But just in case you actually want to know the percents, I did fill it all the way out when I made my tree diagram. Any questions? Alrighty. Zach.
Can you go off the paper, please?
Um,
The general multiplication rule?
Yes.